Hey, on behalf of BIC Magazine and our sponsor, Montrose Environmental, I'd like to welcome everyone to today's presentation on tips for short-term, long-term continuous emission monitoring programs. This is Jeremy Ostberger with BIC Magazine. A few pointers regarding your webinar console. There's a Q&A box on your screen to text in questions anytime during the presentation. Please join us in live tweeting during the course of this presentation and share your thoughts with our Twitter audience. Please use the hashtag BICWebinars. If you experience any technical problems, send a chat message to the organizer and it will be addressed as needed. And now, I'd like to thank our sponsor, Montrose Environmental. Montrose knows that dealing with logistics and implications of environmental issues is vital. With more than 1,700 employees and 70 locations, Montrose focuses on the future of environmental solutions with an integrated approach to design, engineering, and operations. They apply the latest technologies in practical ways to solve difficult environmental challenges of today and prepare for what's coming tomorrow. From lab services to stack testing to regulatory compliance, Montrose helps clients blaze new trails. Hey, go to montrose-env.com for more information. And now it's my pleasure to introduce today's panelist. So our first speaker is Pete Zimick. Pete is Senior Vice President for Montrose Environmental. Pete leads the Emerging Technologies team, and he's worked in the environmental field for almost 30 years. Our second panelist is Greg Birch. He's Regional Vice President of the Gulf Coast region for Montrose Air Quality Services. He brings more than 30 years of industry experience to the Montrose team and has a deep expertise in the refinery sector. Our third speaker is Brian Funke, an environmental professional at Marathon's Galveston Bay Refinery in Texas City. He has done EI, TRI reporting for over 15 years. He tracks daily compliance for over 130 CEMS while reporting downtime for numerous reports across 3 facilities. He helped develop the MACT 5D compliance regimen for the 3 sites through the purchase of handheld testers, which allow the sites to perform tune-ups in-house. He has been responsible for RSR, NSPSDM, MACT CC, and MACT UU semi-annual reports. During this panel session, our industry experts will provide valuable insight in temporary CEMS reporting, data collection, and program startup steps. They will also share their experience with system installation, remote operation, and discuss the requirements of temporary CEMS data used for compliance applicability purposes. Hey, Greg, I want to start with you, and I thank you all guys. Thank you all for joining us. Thanks, everybody.
Thank you.
So, Greg, let's get rolling with you, man. So, what is a CEM, and what types of facilities have them, and what are the basic regulatory drivers for CEMS programs?
Well, there's a variety of environmental regulations that require the use of CEMS, CEMS, to demonstrate continuous compliance with their emission standards. So what we provide during any period of downtime, typically they'll have a limit on how much downtime they can accrue over a fixed reporting period. So anytime they have issues or concerns with their permanent plant CEMS, or if they just want to set up and collect some data for engineering purposes, we provide the option of bringing in a temporary system, either for a short time during a change out, a long-term period, up to several years, or just to provide a backup in case they have a system that has a chronic maintenance issue. So that's kind of where we're at with the presentation. Is we clear up any questions or provide any answers on that.
And Greg, the types of facilities that typically have CEMS, could you tell us a little bit about that?
Pretty much any type of facility that has a requirement for demonstrating continuous compliance with any kind of air rule.
Okay. And Peter, what facilities should they rent? Should they rent to own? What's the typical approach for that side of that decision-making process?
Yeah, there are several options that Montrose offers for temporary CEMS, and they can be rent to own, obviously leasing, or rent to own, and then of course if a customer decides they like the temporary CEMS, they would like that one, or they'd like a new one, of course, we can apply some of that rental period to the cost of the purchase.
Hey, Greg, anything to add on the should facilities rent or rent to own?
Yeah, typically, it depends on the purpose of the CEMS and the period that they may need the CEMS for. If they are looking at leasing a CEMS for a number of years, the purchasing outright may offset the justification for just purchasing the CEMS outright.
And Pete, how do you determine the best technology to use for the CEM?
Yeah, great question again. Obviously, Montrose has a great variety of technologies, and we keep bringing on board some of the latest, greatest, like optically enhanced FTIRs, from taking from the, say, 100 ppb to the single-digit ppb. We have obviously laser type devices and other things, but generally, we'll need to know. We typically will send you a questionnaire, sit down and talk with the customer. One of the things that we'll want to know would be, obviously moisture content of the gas stream, temperature of the gas stream, what are the target compounds, and obviously the most important one, what is the minimum detection limit that's requested or required for the temporary CEMS. So that'll all go into the determination of what technology. Now, there are technologies, obviously, where there's overlap with many compounds, and so typically what we'll do is we'll choose the one that's going to meet your requirements, but is also the most cost-effective option for you. And so we can sit down and discuss that and tell you the pros and cons of the different technologies, and allow you to be part of the decision process.
And Peter, are these indoor or outdoor CEMS?
Actually, they can be either. We offer both types of CEMS technologies. Obviously, if it's indoor, if it's in an air-conditioned control room, HVAC controlled room, that's typically fine for most of the CEMS that we offer. If it doesn't, we can add HVAC to the CEMS unit. If it's outside, we would tend to use a NEMA type enclosure, a weatherproof enclosure. And then again, that is occasionally, depending on if there's area classifications, it might be a class 1 div 2 location. We actually can do that with, say, the installation of, say, a BEVCO type device, which shuts off power should the purge on the cabinet fail, to prevent any vapors reaching any ignition points. We tend to stay away from the class 1 div 1. That's usually very entailed. It entails a long certification process. There's a lot of negligence considerations involved there, and there are technologies that do meet that. We typically don't use those for temp CEMS, but we can certainly point you to those vendors or help you with those vendors if you have an area where you need a class 1 div 1 location.
Hey, Pete, another question in line with this is, hey, do you have area classification systems as it relates to these units?
Yeah, like I said, we can do the class 1 div 2 type systems. We generally don't get a lot of those. It's typically more refinery customers. They have a lot of area classification locations, obviously. Yeah, typically we would find a location that's not area classification, obviously for safety reasons, and then we would run the lines to the process or the stack or the duct, whatever is needed to be measured at that time.
Okay.
So there's lots of different options, and we offer both indoor outdoor units.
Hey, Greg, are the trailers intrinsically safe themselves?
Typically, the type of a trailer that will house a temporary CEMS and for temporary placement is going to be similar to what you'd see on a source test trailer. So those are not intrinsically safe. So considerations should be made to where we're going to park it, regards to unit boundaries and what sort of rules that we need to comply with for unoccupied temporary CEMS trailer.
Okay. And Pete, anything to add to that in relationship to the discussion on intrinsically safe trailers?
Yeah, so I mean, obviously a temp CEMS might be a standalone system that sits outside on a pad somewhere, but it can also be a trailer that has a bunch of CEM systems installed, and it might be multiple CEMs. Generally, the trailers, they are in a rack, and we power up the trailer. We prefer shore power, but we can use generators and other things. So generally, if it's needs to be in an intrinsically safe area, we would not use a trailer. We would typically use a standalone with some type of protection device that turns off the voltage in case there is a leak in the purge of the system itself.
Gotcha. Yeah, that's important. Pete, I'm going to stick with you on this next question. What are the advantages of point versus open path?
Yeah, yeah, we actually do offer open path temporary SIMs in the state of California. Practically every refinery there has multiple open path systems, being open path FTIR, open path UBDOAS, open path TDLs, and various extractive units also that supplement those systems. We do offer temporary SIMs in case one of those systems go down. We can put in open path systems to take up the slack, or we might even use something like our proton transfer time of flight mass spectrometer van that can basically circle the facility and take measurements of the ambient air at the fence line as well, if not better, than open path systems. But we offer both types of systems. Obviously, extractive, which is where you pull a sample into an enclosed sample cell and take a measurement. That's a measurement in a point in time and space, whereas open path systems can measure across a fence line literally up to 1 kilometer inland, or 500 meters out and 500 meters back.
Wow. And so do you test multiple sample points, and what are the benefits of that?
Yeah, good question. When we're talking about open path systems, the ones in California are used primarily with one target. In other words, you have a telescope, sends a signal to a target, that gets sent back to the telescope, and then the measurement is made. Now, that's kind of just an alarm system. It can't tell you whether you've captured the entire plume. It can't tell you the maximum concentration of that plume. It's what's called a path integrated average. But we can put out multiple targets, and then by putting out multiple targets at various distances, we can then determine the extent of the plume and actually the distribution of the plume, which can then be used for modeling or flux measurements. In terms of extractive systems, again, for ambient extractive, we rent and we sell multi-point analyzers. In other words, they can have 20 sample points, and you can run lines out from one central location to various places in the facility. We do that a lot with ethylene oxide nowadays. Or we can obviously just a single point where we're measuring, say, an emission point, a stack, a duct, or other things like that. So it really depends on the application, whether you want multiple points or you want one single point.
Gotcha. And Greg, how do you know if you have a leak from a cylinder or a sample stream?
Typically on the temporary SIMs on our cylinders, we're going to have a Bluetooth pressure transducers that will communicate, and we monitor that on a regular basis. So we'll get reports if we start losing pressure. Otherwise, on the sample stream in the trailer, we may not see that until something goes awry with the sample signal, or we also have 4-gas monitors, explosion-proof monitors in the trailers in the event that we're monitoring a flare stream or a fuel gas stream or something like that that could be a hazardous source. We will be able to pick that up with our detectors in the trailer, and those will alarm for us.
Pete, anything to add to the question about how do you have a leak from how do you know if you have a leak from a cylinder or sample stream?
Yeah, sure. Now, obviously, when these are installed, we would obviously send a person down to site. They will leak check the entire system from tip to stern. But what usually will sometimes happen is obviously, a plant personnel or even one of our guys will come swap out a calibration gas cylinder or other type of cylinder that the instrument needs to run. And that's where most of the leaks occur. So what we can do is we generally will, as Greg has stated, we monitor the pressure on the cylinders to make sure they're not dropping precipitously, obviously indicating a leak. And we can even send out video to a control room or log in daily to make sure that everything is running properly and all pressures are correct.
Okay, so let's get into data delivery. Greg, how is data delivered?
That depends on the need of the facility typically. For a very short time, temporary CEMS, we typically will not tie directly into the plant system. What we'll do is we will upload to the cloud and then deliver the data in like an Excel type format. Or if the plant prefers, they can run leads into the trailer and tie into their DCS to read it in on a 4 to 20 milliamp signal. We also provide the ability through a internet platform, through GoToMyPC or something like that, where we can provide a password and individual login for the facility so they can log into their system and monitor the CEMS remotely, take a look and see what's going on.
Okay. Is that a pretty easy format? Brian, want to flip this to you. Can you share your experience and how you use the data at Marathon?
Yeah, like Greg said, it comes to us in a variety of ways. We get it in a PDF format, which is kind of the monthly summary of all the daily validations and any pass or fails and the cause of corrective action. But then they also send me minute data in the Excel spreadsheet for whichever of the constituents that they're monitoring for us. And then I take that data and I format it, have it uploaded into our Pi data historian so that it can be used in our calcs and that we have a record of that data. So if future questions come about, we can have the data in the Pi historian and we can pull it up anytime we need it.
Okay, great. Hey, and this goes back to Greg. Do you need an internet access to the CEMS? That's Brian kind of mentioned that, but what's the internet requirement? Yeah,
that's a good question. We typically do ask that we're able to have internet access. We don't ask for that through the facility. We have our own hotspot device that we have installed in the trailer. And by doing that, that provides us a window to look in remotely and observe 24 hours a day. If the operations calls and asks us to take a look at the system, we can do that anytime, day or night. Without that access, then we fall back on relying on the facility to have an operator, have somebody stick their head in the trailer on a continuous basis, and we won't know if there's a problem unless they call. Otherwise, with the internet access, we're able to set up our system to be completely automated to where we perform the daily calibrations and get the emails, the calibration drift emails, and we can continually assess the data without being on site.
And Pete, do you have anything to add in regards to the internet access to the CEMS topic?
No, I would just add that, obviously, TCP/IP Modbus is the easiest, right? Because you can send out alarms that way. It's very quick and easy as opposed to running twisted pair for 4 to 20. 4 to 20 is your gold standard. Very difficult to intercept or manipulate. The TCP/IP, IT would have to be involved to make sure that if we are sending it to, say, a control room PC or a data acquisition system, that it be properly set up, that it's with one-way switches even or firewalls, so that somebody can't obviously hack into their intranet system. We certainly don't want to be the portal for that. So at the least, if they can even temporarily give us access when we need to check the system, periodically, and then disconnect, so we're only on there for minutes at a time. That also is secure, but obviously with temp CEMS, generally we're there because there's an emergency. Their CEMS is down, and unless they get it up and running, there's going to be repercussions from that, regulatory as well as monetarily. So obviously sometimes it's easier to get that access, but that's something that first and foremost has to be discussed with the facility.
And Brian, you know, how do you balance those conversations between IT with your immediate need and get that data up and running?
Well, our immediate concern is always getting the temporary online and starting to pull data, so that way that stops the downtime accrual on our side, and then we work with Montrose and our IT guys to figure out a solution to, like Pete was talking about, either 4 to 20, or we do a mod bus and get the data into our DCS. And sometimes that happens real quickly, and sometimes it takes a little bit longer. It just depends on the you know, workload of the IT guys.
Yeah, makes sense. And Greg, can you provide alarm outputs for excessive emissions?
We can, along with the continuous data output streams, we can provide alarms for various outputs, whether it's a excessive drift or an emission exceedance or anything along those lines. It just we can customize the alarms to suit the needs of the customer and what they're looking for.
And Pete, anything to add regarding alarm outputs?
I would just add that, you know, obviously that, like I stated before, the TCP/IP makes it easy to send alarms. The twisted pair, we can send an IO that will trigger a visual alarm or an audible alarm, or even turn on a process fan or something to that effect. So yeah, a lot of our systems have low, mid, and high alarms. All of our FTIR systems do. When you get into GCs, generally there's fewer. We might have to add a PLC to a system so that we can send out the proper alarms, or combine streams, or do some type of arithmetic calculations. Obviously, mass emissions, you know, we use those when you have to convert from concentration to mass emissions, and you need a volumetric flow rate. So there's various ways that we can do that with alarms, but we can, again, it's up to the discretion of the customer how they would like that data alarm set up.
Hey, Greg, how do you know if the CEMS fails?
Typically, we'll do the daily calibrations and we'll get the reports. So frequently, we'll find out with the daily calibration. Otherwise, if the CEMS has a continuous feed into the control room, or if the operators are keeping an eye on it, we may not know unless they call us directly. So they will be the first line of monitoring to see if the system goes down. Addition to that, as part of that, the process knowledge, they may have a better knowledge on what their expectations are to see coming out of the CEMS than we might have. So if the CEMS develops a leak or something isn't operating right, we may not recognize that as quickly as the plant personnel do. So they may call us and just advise us that we need to come down and take a closer look. And then once we get that, we can actually run through some maintenance checks via the internet immediately. Frequently, we can solve issues within 10 or 15 minutes remotely. Otherwise, we'll respond directly to the plant to start troubleshooting and getting corrective action going.
And Brian, with your experience with the system, you know, how do you guys handle that? How do you know if the CEMS fails? Is that in line with what Greg said?
Yeah, pretty much what Greg said is a lot of times we'll have an alarm on the board, and that'll kind of come up and show, you know, error or not getting data, and they'll acknowledge that and kind of dig in and say, okay, we've lost data signal, and then they'll, you know, go out and check on the trailers, see if maybe if we're on diesel generator, if we ran out of diesel or something like that, or if the power somehow got disconnected, and then they'll typically call myself or somebody that's on call to say, hey, we need to get this trailer looked at and get Montrose back out here to get this thing back online.
Gotcha. And Greg, you know, how fast is emergency response?
It typically depends on the distance we are from the facility, but normally we can respond remotely immediately. If we have to mobilize to the facility, we try to be there within a matter of 3 to 4 hours. Certainly, if we have to travel to get there, it takes a little bit longer, but the emergency response, if we have a failed CEMS, is we always try to get the system back up and running within 8 hours at the most, but typically we'll be on site troubleshooting it within 3 or 4 hours. As far as a placement of a new temporary CEMS, if somebody has a catastrophic failure and it comes up as an emergency, as it frequently does, we keep a supply of equipment on hand. We have some offices strategically located across the country to be able to supply temporary CEMS on a short notice. So we try to be able to get something going in the field within a day. For remote locations, it may take longer. Worst case scenario, no more than 5 or 6 days. So it depends on the proximity to our offices and where we have the equipment.
Gotcha. Hey, Pete, anything to add in regards to, emergency response?
Yeah, I would just add, Montrose has many offices, 70 offices across the U.S. and Canada and Canada. We do work in Mexico too. So obviously logistics is very important. An area like Houston, very dense industrial area, we have several offices, Baton Rouge, Houston. So getting someone on site is not a problem. We've easily had 24-hour turnaround time for something like that. There's a problem, send somebody in just even to check things out or change a diaphragm pump, a diaphragm on a pump, right? Because the pump's not pulling.
Mm-hmm.
Those are kind of the typical types of issues you would come up against. Usually they'll last a year. Sometimes they'll fail before that. But at the most, it's, within 48 hours. It's just sending someone down from one of our other facilities on a plane within 24 to 48 hours, and we'll get that system up and running. Now, for the more common CEMS, right, which would be GC based, FTIR based, generally we can, if there's a catastrophic failure, as Greg has said, we can send another temp down pretty quickly.
Okay, let's get into data backup. Greg, how is the data backed up?
Well, as we've learned from experience, we can copy that data directly to multiple hard drives in the trailer, but currently we also upload on a continuous basis to the cloud, so the data is never lost. At the same time, if we are outputting to the plant DCS system, the plant's storing the data, but separately, we do provide backup and cloud-based storage on a continuous basis. So if the hard drive in the trailer does go down, nothing's lost.
Hey, Pete, anything else to add in regards to data backup?
No, I would just add that, if it's critical data, obviously, usually it is, we'll have a secondary hard drive that's
Okay.
emulating the first hard drive. The chance of both going down is slim.
Okay, great. And Greg, will the operations personnel have access to the CEMS data or just the environmental contact in a typical environment?
We leave that up to the client normally. We do provide remote access, and normally the operations has direct access to the trailer, but we provide a means of logging in remotely through go to my PC or something similar to that, and everybody will have a unique password. However, we do limit access at times. Providing that access also gives them the ability at times to manipulate the data collection. So they could just through clicking on the screens inadvertently turn off the data collection, and we try to avoid that. So we do provide the access, but we provide that with the caveat to use caution.
Hey, and Brian at Marathon, Texas City, how do you guys handle access to the CEMS data?
Yeah, it's like Greg said, we'll have that go to my PC for the initial access, and if it's only going to be there for a short time, we'll have limited personnel that have the login to that, so that we don't come across a situation like Greg described where they click somewhere and affect the analyzer in some way. Then with the longer term, we'll run into the DCS, and then everybody's happy because it's all on the board like it used to be.
Okay. And Greg, how frequently can one expect to be on site to service the CEMS,
It really depends on the type of CEMS that we're operating out in the field. Some of the more complex GC-based CEMS may require us to be on site every day to put our hands on it and make sure everything's functioning properly. However, even with the GC CEMS, we can normally set those up to where we can calibrate them and maintain them remotely to where we're on site maybe once or twice a week. With the flue gas exhaust CEMS, we can automate all the functions on that and monitor them remotely with enough confidence that we really only have to be on site every 2 to 3 weeks.
Okay. Pete, anything to add there in regards to what one can expect to be on site to service the CEMS?
Yeah, no, just as stated before, we're very responsive. So typically servicing was within 24 hours.
Great. And so how does your downtime impact getting your temp CEMS on site, Brian? Could you address that?
So it kind of just depends on the level of downtime already accrued by whichever CEMS is in question. Obviously, the higher the downtime, the sooner we want it out there. So we get up close to that 5% downtime range. We, of course, want that analyzer out there yesterday. And we've routinely called Greg at 3 o'clock on a Friday afternoon and said, hey, can you have this out here like right now? So that's been our standard response. But it just really depends on the level of downtime. So if the higher it is, the more critical it is.
Okay, great. Yeah. So Greg, how do you provide BTU for the FlareSims?
For the FlareSims, historically, in the past, we used a micro GC based platform, which gave us one data point every 10 minutes, and we would feed the breakdown. It was like a ASTM 1946 type analysis where we speciated all the C1 through C6 and fixed gas compounds and calculated BTU and molecular weight from that. We've moved over, updated the technology to a mass spec now, which gives us 5-second data points. And basically, we're still doing the same arithmetic through Excel to calculate the heating value. But with the 5-second data points, we can capture much faster, get a much better response, and we're down for calibrations less than 15 minutes.
Pete, any comments on providing BTU for the FlareSims?
No, I would just add that there are some other things sometimes we will add to these systems. Obviously, if hydrogen is high in the process or the flare header, nowadays they do count that is the BTU contributor. So we'll add a separate hydrogen analyzer, but that's integrated into the CEM, so you get one number for the total CEM, the total BTU. Or if say someone, a plant says, no, I want to use calorimetry or some other technology for total BTU, that's fine. We can source that, or we can build one for you pretty quickly.
And there's a question income from the audience, and Pete, I'll stick with you. Is a relative accuracy test performed on the temp CEMS, or is it calibrated daily as a reference method analyzer?
Good question, but a complicated question.
Pete, I'll take that if you want.
Yeah, Greg, if you want to start, I'll add some to it.
Sure. Typically, we try to operate the temporary CEMS in accordance with the performance specifications from Appendix B. So the question is it calibrated on a daily basis as a reference method analyzer? That's kind of a yes and no question. It's calibrated daily in accordance with Appendix F. So we'll do 0 and a high level calibration daily and analyze the drift as is required by Appendix F. The first part of that question is a relative accuracy test performed on the temporary CEMS. That is also dependent on the type of CEMS it is and how long it's going to be on site. If we're set up just to perform a maintenance support during a bundle change out or something like that, where we're going to be on site for less than 2 or 3 days, maybe even up to a week or so, the generally not required to perform a relative accuracy test on that. However, when we install it, we'll certify it with a Alt-RA from performance specification number 2, which is basically a glorified cylinder gas audit. But we do provide the quality assurance audits when we do install the CEMS. If it's installed for a long enough period of time to justify performing a RADA, we'll bring in a separate unit to perform as a reference method platform and certify the CEMS with a RADA with the secondary CEMS. And certainly on a multi-year temporary CEMS, it'll fall in with the typical Appendix F quality assurance requirements of requiring the annual RADA. Additionally, if it's on site, as soon as we get it on site, we're going to start the 7-day drift and provide that as part of the certification.
Pete, I think you had something to add to what Greg just said.
Well, Greg covered a lot, most of it. That's great, but obviously some technologies, depending on the technology or depending on the compound, that'll dictate the performance specification required. Like if you're using an FTIR, it's PS15, right, which is actually a little vague. So whether you have to do a dynamic spike every day or not, that's something that's clarified with the regulatory agency. We would generally run the same requirements that you had for your full system CEMS and follow those requirements. Now, the difference between a performance specification and a reference method is that the performance specification is generally for a CEMS, but when you do a RADA, you're either doing a statistical analysis or bringing in another system device and comparing those two, and then you're performing an EPA reference method to ensure that you have good QA/QC numbers and meet all the requirements. So there's some slight differences between PS15s and reference methods, but if it's a CEM and there's a performance specification, that supersedes, so that has to be done.
Yeah, just to add to that, if I could, frequently we'll plan some of these well in advance, and if we have the capability and the time allows, say for a new CEMS install or something like that, we do like to submit a test protocol to detail the operations and the planned operations of the temporary CEMS that we can, the client can submit to the state to make sure that they have buy-off and everybody's in agreement of how we're operating it and the quality assurance that steps that are being performed to maintain it.
Thank you, guys. Good response to a great question from an attendee. Greg, I'll stick with you on this next question. Do you calculate CEMS emissions for comparison to emission standards?
We can do that if the client asks us to. In the event that we would be asked to calculate pound per million BTU, as long as they can provide a F factor or composition, or we can correct to percent O2 for emissions comparisons. We can also calculate mass emission rates, but then we get back into requiring some flow measurements or flow emission data.
Pete, anything to add in regards to that question?
No, I would just add that, obviously your permit is going to dictate how you manipulate that concentration number to report the final required number, whether it's pound per million BTU or corrected to 7% oxygen or on a dry basis. So we will add those additional features to the temp CEM, such as an O2 monitor, CO2 monitor. Generally, FTIRs give you moisture. There are other ways to do that too, but we would sit down, like Greg said, with the regulatory agency and make sure they sign on the dotted line that what we're putting in is acceptable.
And Pete, what if you need flow measurements to report mass emissions?
Yeah, well, obviously, if your CEM goes down, it doesn't really mean that your flow device has gone down. So obviously, we would try to use that flow device, right? We don't want to interject an additional unknown accuracy, right, to that measurement. So we would try to use that, but we do have other types of flow measurement devices, whether they be just a standard pitot tube that even a guy can come in and traverse periodically, or we'll use a pitot array, a propeller anemometer, a hot wire anemometer, depending on the needs of the particular application. But sometimes it's just as easy as installing a fixed pitot with say a Delta P EMRC device that works off a 4 to 20 milliamp, and that goes into our CEM system, and the calculation is done on board.
Greg, I want to give you the opportunity. Any points to add to what Pete just said?
No, I think he pretty much covered it. If we're going to be calculating mass emission rates, we are going to need some flow measurements, and we can put in a system that will measure those as well, or we can take those from the facility. Certainly on something where we're calculating mass emission rates, where we can calculate it based off of method 19 calculations, we would require really need a calibrated fuel flow meter. But with the fuel flow meter and the F sub D, we can provide mass emission rates for anything that could be reported through method 19.
And this question with a hurricane looming in the Gulf and what we've experienced along the Gulf Coast the last few months is a good question. So what about power for trailers, and are generators a good option, or do you recommend finding a shore power source? Greg, I'll go to you with that question.
You know, that's a good question. You brought in the hurricanes as well, and that adds another spin to it. But we generally try to avoid running temporary CEMS off of generators if we can. For short-term applications, they work. However, generator power is generally not real stable, and as the power fluctuates, it could affect our analyzer readings. So shore power is always preferred. But since you touched on the hurricane thing, you know, when we run these systems frequently for short term, we're going to run them just like a source test with a heated sample line. So when we install them, we will secure those sample bundles to the structure in a way that when we get winds like we're expecting in the Gulf Coast for the next few days, hopefully those won't be affected too much. And same thing with the trailers. Those can be secured and tied down to where they don't become a windborne hazard during a hurricane, I hope.
Hey, Brian, Marathon's been through some of these issues. Tell me about your thoughts on power for trailers, and are generators a good option at your site, and finding a shore power source? Just wanted your comments on that question as well.
Yeah, like Greg said, generators are always an option, and lately it's been our only option because of our welding receptacles, or the 480 power that they need is not local enough and are reachable by the cord for them. So we generally go with generators, and sometimes we've had them out here running on generators for a couple of months at a time, and we have had issues where they run out of diesel and they shut down. So what we've taken on our side to do is have a new installation for our CEMS. We will build a welding receptacle in with the CEMS shelter, so that way they can plug right into the CEMS shelter, and then there's a 480 power that they need for running the trailer for them.
Awesome. Hey, Pete, what's the recommended length for heated lines?
Yeah, another good question, and complicated question. It depends on various things. One, how hot the heated line can get, right? Two, what are the target compounds? Are they quote unquote what we call sticky compounds? Ammonia, formaldehyde, HCl, acid gases, even SO2. You can't get SO2 through a line unless it's hot. So, you know, personally, we like to stick to 100 feet if we can get within 100 feet of the source. Now that's not a stopgap. I've done cement kilns with 350 feet of line and passed the dynamic spiking, which is a sample bias test, sampling system bias test. So, you know, it depends on the compound, the concentration of the compound. But for the most part, if you're within 200 feet, you're probably 95% of the time okay. But again, that is something that we will determine once we know what the target compounds are and the moisture content and what the boiling point of those compounds are, because the line obviously has to get above that too. Can't be any cold spots on the lines, because that's a sure failure right there. You know, more line means possible leaks between connections. So generally, you know, we'll work with you to try to get the shortest location And sometimes we'll even close circuit, which means we'll put the CEM right up on a platform right next to the stack. It's a very reactive compound, and you absolutely need to have pass this dynamic spike recovery testing or any other types of recovery testing for that target compound.
Okay, thank you. Hey, Greg, can you walk us through a standard test plan?
Certainly, typically a standard test plan that we'll provide in advance of the temporary CEMS installation. We'll cover all the quality assurance requirements, any permit requirements that we have to identify with the temporary CEMS, emission standards. We'll set up the operational ranges and spans of the analyzers. We also try to address any safety concerns or meet any JSA requirements. Every now and then a facility may require an MOC for a CEMS install if there's something that needs to be affected by on the plant or operation side. So basically what we want to do is provide a test plan just to make sure that everybody's on the same page so we don't get any surprises once we get on site. We know what we're getting into as far as the CEMS setups, the calibration requirements, and the client knows what to expect from us.
And Greg, kind of adding to that, can you discuss the certification of the temporary CEMS?
Certainly, we touched on that pretty heavily with the question about the relative accuracy test audit. Once we install a temporary CEMS, depending on the length of time it's there for, we'll go into a 7-day calibration drift assessment. If it's there for a long enough period of time, we will follow that up with a relative accuracy test audit. Certainly, we will the setup day and the initiation day, we'll do the alt RA, which is a cylinder gas audit, basically. And then from that point forward, we will perform the daily calibration drift assessments. Typically, those are going to be performed automatically through our data acquisition software, which will also provide an email. And we can add as many people to that email as is desired. So the plant environmental people can have that daily email verifying that the system has passed and its operations. We will also provide typically we provide a monthly report that presents any out of control periods or maintenance actions for that time period. But we've also been requested to provide them on a more frequent basis, so we can adjust that schedule to send out as many reports as a client would like to have, and we can include any alarms, any and all alarms in those reports. So we operate them fully within Appendix F guidelines and provide all the visibility that a client may request.
Brilliant. Hey, Brian, have you experienced the CEMS go down unexpectedly? I just wanted to get that question over to you.
Yeah, late last year, mid-November, we had an incinerator analyzer that just started looking weird. We started accruing some downtime, and we'd go out and fix it, and they'd have more downtime. We got to that point where we were having a high accumulation of downtime, so we called Montrose and had them bring a temporary CEMS out. And not long after they brought their temporary CEMS out, ours pretty much just died. And so we proceeded to order a new one, and then it's been, a long road with everything we've had to go through this year. We've had a temporary CEMS or temporary analyzer for Montrose in place since then, and we are close to getting a replacement brand new analyzer delivered and installed. So yeah, oddly enough, we have had that happen recently.
Good luck with the install, Brian. So folks, we're going to wrap this up. I just really wanted to thank all of our panelists for presenting and being a part of this. Greg, Pete, Brian, really appreciate your time. Thank you all.
Thank you.
And
Thank you.
Certainly want to thank our sponsor, Montrose Environmental. Please, everyone visit them at montrose-env.com. And look, this on-demand version of the presentation will be available about 2 hours from now at bicwebinars.com. Feel free to watch it again, and please share it with your colleagues. On behalf of BIC Magazine, we say thank you.